Hi guys, the purpose of this additional resource is to challenge you guys into utilizing what we've just learned so far in our algebra unit into taking a look at a new type of problem that at first glance might look like something that is completely unsolvable, but taking a look back and tapping into what we just learned, breaking down that problem to ask yourself, is it solvable? And if it is, breaking down to finding a solution to that problem. So let's start by going over and reviewing some of the two-step equations we've learned up to this point. So I have two examples right here. First example is 5x minus 2 is equal to 8, and the next example is x divided by 4 plus 3 is equal to 13. So one at a time, let's go ahead and solve each equation, kind of utilizing what we've done. They are two-step equations, so it's going to take 2 steps to isolate that variable. Remember, because there are 2 steps, not only do you want to do the opposite math, but also in the opposite order. So we're going to start off with this one by adding 2 to both sides. Got to keep it balanced. Get rid of that minus 2 first. The whole reason we added 2 was to get rid of the minus 2, so get rid of it. We're left with 5x is equal to 10. All right, so now what's pretty nice here is we've got a one-step equation. 5 times x is equal to 10. Well, x is being multiplied by 5. Let's do the opposite to both sides, which is to divide by 5. That takes care of the multiplication of 5. So we're left with x is equal to 2. Okay, let's check it real quick, make sure it works. So 5x minus 2 is equal to 8. 5 times, we're saying it's 2, minus 2 is equal to 8. Oops. All right, 5 times 2 is 10, minus 2 should hopefully be equal to 8. 8 is equal to 8. Oh yeah, that's true. All right, it checks out. Okay, let's try another one. What's different about this one is we have that fraction portion, but remember, x over 4 is the same thing, oops, writing my words backwards, as x divided by 4. So keep that in mind. If you need to rewrite it, go for it, okay? But just like the last one, it is a 2-step, so we've got to do the opposite math in the opposite order, which means I'm going to tackle this plus 3 by subtracting 3. Okay, so that gets rid of my plus 3. I'm left with x divided by 4 is equal to 10. All right, so I'm left with a pretty nice one-step equation. X divided by 4 is equal to 10. Gotta get rid of that division by 4, so I'm going to multiply by 4. Both sides to keep it balanced. That cancels out, so I'm just left with x is equal to 40 for my solution. Let's check it, of course. So x divided by 4 plus 3 is equal to 13. I'm saying x is 40 divided by 4 plus 3 is equal to 13. All right, 40 divided by 4 is 10, plus 3 is equal to 13. 13 is indeed equal to 13. All right, so our solutions check out here. So this is just a real quick recap of what we've already learned to do so far in this unit. So I want you to think about this review and the information we've learned, and I want you to apply it to these new problems I'm going to show you on the next page. Okay. So I've got 2 different problems right here. They're still equations because I've got a combination of numbers, variables, operation symbols, and your equal sign. So it is something we can solve. So let's see if it really is solvable. 2/3 x is equal to 30 is the first equation. And the second equation is 1/6 x minus 1 is equal to 2. Okay, so looking at the first one here, I know that my variable is x. It is not by itself. It is being multiplied by 2/3. So we would, of course, have to do the opposite, which is to divide by 2/3. Is it possible to divide something by 2/3? Have we learned at any point this school year how to take any number and divide it by 2/3? Let's see here. Let me kind of write this out. So hopefully I can notice something that looks familiar. So I need to take 2/3 x and divide it by 2/3. Okay. Do it to this side as well. 30 divided by 2/3. I'm not too concerned over here that it's a fraction because I know that multiplying and dividing by the same thing will cancel out. So those do get rid of each other and I'm just left with x. But is there a way for me to simplify this? And I'm hoping at this point you guys do see something that looks familiar. Sure, I've got a whole number divided by a fraction. That is a little bit messy. No big deal. Turn that whole number into a fraction by writing it over 1. So now we've got a fraction divided by a fraction, which we know how to solve. Okay, so let's recap really quickly how to divide fractions. When you're dividing fractions, remember you need to make a few changes. You got to leave that first fraction alone. You have to find the reciprocal of the second fraction or flip it. Once you do that, you're now multiplying. Okay, now remember when you multiply, numbers get bigger, and the bigger fractions are harder for us to simplify at the end. So let's see if we can do anything first before we do that multiplication. Check on a diagonal. 1 and 3, there's nothing you can do because 1 is the smallest number you get in a fraction. 2 and 30, ooh, I can divide both those by 2. Okay? So now I have a problem that I can go ahead and solve. So x should be equal to, all right, 15 times 3 is 45 over 1, which is the same thing as just stating that x is equal to 45. So to answer that first question of is this solvable, the answer would be yes, because you're still doing the same two goals in algebra, isolating that variable while keeping it balanced at the same time. Okay? Now remember, to isolate that variable, you got to do the opposite of what's happening to it. So it doesn't matter if we're working with whole numbers, decimals, or fractions. What's nice is at this point in the school year, we have worked with computing all three types of numbers. So you will be able to take a look at any equation that I give you at this point. And if there's no whole numbers, no need to panic. We do know how to work with them if they are fractions or if they are decimals. They are still solvable problems. Okay. Let's take a look at the next one together because it does look a little bit more complicated. However, it's nothing we need to be scared of. Got 16x minus 1 is equal to 2. Looks like I got myself a two-step equation. So I'm going to have to not only do the opposite math, but in the opposite order. Okay, so since I would normally do that subtraction last, I'm going to tackle it first. I know how to get rid of minus 1. I'm going to add 1. Okay, clean that up. That cancels out. So I've got 16x is equal to 3. All right, so I have my x is not by itself. It's being multiplied by 1/6. So I've got to do the opposite, which is to divide it by 1/6. So I need to do that to both sides. 16x divided by 1/6 is equal to 3 divided by 1/6. Okay, I know that those cancel. That's the whole reason I did it. So I'm left with x is equal to, all right, let's go ahead and solve this. 3 divided by 1/6 is the same thing as 3 over 1 divided by 1/6. To divide fractions, I have to leave the first, flip the second, and multiply. Check on a diagonal. Nothing I can do here because I'm working with some ones. Alright, so x is equal to 3 times 6, which is 18, over 1 times 1, which is 1. That is also simply stated as x is equal to 18. So to answer that original question of is it solvable, of course it is. If you have an equation that contains numbers, variables, operation symbols, and an equal sign, use your algebraic way of thinking and working backwards using the opposite math that's already happening to break down that problem one step at a time to find the solution. What I want you guys to do now after watching this video is go over to the side counter, and I want you to grab the paper that is titled Is It Solvable? And there's just a few more examples I want you to run through and solve for me.